December 31st, 1999. The world is buzzing. In New York, crowds gather in Times Square. In London, fireworks wait to be unleashed. In Tokyo, people prepare for midnight. But behind the celebrations, there's fear. Will planes fall out of the sky? Will banks lose track of money? Will the power grid shut down? All because of something called the Y2K bug, the Millennium Bug. It sounds silly now, right? A computer bug that could bring down civilization? But back then, people were genuinely scared. News anchors talked about it daily. Governments ran emergency drills. Companies spent billions. Some people even stockpiled food and water, convinced modern life was about to collapse. And then midnight hit. The year 2000 arrived. Fireworks lit up the sky, and nothing happened. Planes didn't crash. Banks didn't fail. The lights stayed on. For many, Y2K became a joke, a story about panic over nothing. But here's the twist. The only reason nothing happened is because people fixed it. Engineers spent years rewriting code, line by line, system by system, patching the flaw. It was a quiet, behind-the-scenes victory. Y2K wasn't a hoax. It was a crisis that was averted. Now here's the part most people don't know. Y2K wasn't the only time computers faced a time-based disaster, and it won't be the last. In fact, the next big one is already coming. It's called the year 2038 problem, or Y2K38. And in many ways, it's even scarier than Y2K because it goes deeper. It's not just about how we wrote dates, it's about how computers perceive time itself. Here's how it works. When you look at a calendar, you see days, months, and years. But computers don't think that way. They count. Specifically, many systems count the number of seconds since January 1st, 1970, at midnight UTC. That moment is called the Unix epoch, the birth date of modern digital time. Think of it like a stopwatch that's been ticking since 1970. Every second since then gets added up into a big number. Computers don't see 2025, they see a number in the billions. But here's the catch. For decades, that number was stored in a format called a 32-bit signed integer. Without getting too technical, that means it can only count up to about 2.1 billion seconds. After that, it rolls over, just like a car's odometer rolling back to zero. And that limit runs out on January 19th, 2038 at exactly 3:14:07 UTC. At that moment, the counter maxes out. 1 second later, it overflows and flips into negative numbers. And negative seconds from 1970? That points back to December 1901. Suddenly, computers will think it's the dawn of the 20th century. Now maybe you're thinking, okay, weird, but what's the big deal if a clock is wrong? Here's where the aha moment comes in. Time isn't just cosmetic in a computer. It's the invisible skeleton that holds everything together. Timestamps control when tasks run. They mark when files are created and deleted. They validate your credit card expiration date. They log financial transactions down to the millisecond. They schedule surgeries in hospitals. They tell planes when maintenance is due. They guide satellites orbiting Earth. Without accurate time, the logic of modern computing collapses. Imagine logging into your bank only to be told your account expired in 1901. Imagine a hospital's scheduling system believing your surgery was due 137 years ago. Imagine a stock market algorithm suddenly backdating trades a century. The effects wouldn't just be weird, they could be catastrophic. And here's the kicker. We've seen this before. Not just in Y2K, but in other time-related bugs. In 2012, the leap second bug struck. Computers around the world froze when a single extra second was added to the global clock. Major websites like Reddit, LinkedIn, and Yelp crashed. Airlines grounded flights. A single second caused worldwide outages. In 2020, GPS weak rollover caused some older navigation devices to suddenly jump back to 1999. In 2014, an Excel bug caused problems for NASA because the program couldn't handle dates past 1900 correctly. Even the Apollo missions faced software issues because of calendar assumptions. And let's not forget the Zune music player crash in 2008, when every Zune on Earth froze because the software couldn't handle leap years. These weren't hypothetical problems, they really happened. The year 2038 problem is the same kind of issue, just on a bigger scale. It's baked into the way millions of systems keep time. It's the odometer rolling over, but this time it's global. So, what's the fix? The solution is to move from 32-bit time to 64-bit time. Instead of maxing out at 2 billion seconds, 64-bit can handle more than 9 quintillion seconds. That's enough to last 292 billion years, longer than the universe has existed. Once we move to 64-bit, this problem disappears for good. The good news? Most modern systems have already made the switch. Your phone, your laptop, the servers running YouTube, they're fine. But the world doesn't run only on modern tech. Banks still rely on decades-old mainframes. Governments still use ancient code. Factories run machines designed in the 1980s. Cars, satellites, industrial systems, even medical devices, all filled with embedded chips that may still be counting time the old way. And many of those devices can't be updated easily, if at all. That's the danger zone. Now here's where things get really interesting. The year 2038 problem isn't the last bug we'll face. There are others on the horizon. For example, the year 2100 problem. Our calendars assume that most years divisible by 4 are leap years, but 2100 won't be a leap year, and some software might not account for that. There's also the year 10,000 problem. Believe it or not, some systems already can't handle 5-digit years. Or the year 292,277,026,596 problem, the moment when even 64-bit time finally overflows. That's so far in the future it's almost funny, but it shows just how deeply these time bombs are buried. And there are smaller ones too. GPS rollover happens every 19.7 years because GPS time is stored in a 10-bit field. It's already caused problems in 1999 and 2019. The leap second issue still hasn't been fully solved. Every time the Earth's rotation slows and we add an extra second, some systems glitch. These are mini Y2Ks that keep popping up. So is the year 2038 problem the true successor to Y2K? Yes, absolutely. It has all the same ingredients, a hidden flaw buried deep in our systems caused by programmers making assumptions decades ago. A flaw that most people don't know about, but that could cause chaos if ignored. And just like Y2K, it can be fixed if we prepare. That's the final lesson. I2K wasn't a joke. It was a massive global effort that succeeded. It's the reason the world didn't collapse on January 1st, 2000. The year 2038 problem will require the same kind of effort. Quiet, behind-the-scenes work by engineers and programmers, work that nobody will thank them for, but that will keep the world running smoothly. If they succeed, most people will never even notice. And maybe, in 2039, some will laugh and say, "Ha! Remember when people worried about Y2K38?" But the truth will be the same as before. Nothing happened, because people fixed it. So the countdown is already ticking. Tick, tick, tick. January 19th, 2038 isn't that far away. The question is, will we be ready? Or will we learn the hard way that in the digital age, even something as simple as time can bring the world to its knees?